Okay, now in this video, we'll be seeing how the EIGRP process actually happens initially whenever you advertise on any two routers. So let's get started. So we got two routers here, router A and router B on the right side. So I'm going to give some IP addressing. Let's say the IP addressing on the router 1 or router A is 10.1.1.1 and 10.1.1.2. So let's say these are the IP addresses what we have on the WAN interfaces. So initial process by default, EIGRP protocol works based on advertisements. So if you want to exchange the routes, we need to advertise on our own directly connected interfaces. So let's say the router 1 is advertising this interface. So by using some network command, just like we do in RIP, we just say network 10.0.0.0. Whenever you advertise this network under the router EIGRP protocol mode, so it's going to send a hello message. So the initial process, first time whenever you advertise this interface, it's going to send a hello message to router on that particular link. It's saying that hello, I'm router A. Generally it will be saying that I'm 10.1.1.1, that is my IP address, or that is my ID, and is there anyone on the link? And this hello message, initially it will be sent on a multicast address. 224.0.0.10 is the multicast address used by EIGRP. So which means all the routers, or whatever the router running EIGRP, they will be listening on this multicast address 224.0.0.10. Okay, so by default this router B will not listen to that message because now it is not running EIGRP. So once you advertise this interface also, then using the same network command, that interface also will start listening to that EIGRP message. So it is going to listen to that multicast message and it is going to reply to that hello message, saying that again it is going to reply with the same hello message saying that hello, I'm router B, or it will say I'm 10.1.1.2. Generally it will be the IP address, it will not be a name. So just for easy understanding, you can see the routers are referred as A and B, but actually they will be the IP addressing. So the reply will come from the router B after listening to that message, and the reply will come as a unicast message. So this is the initial process, what happens first time whenever you advertise the interfaces. So probably we'll see this practically, we'll verify this behavior as well. And this is the initial process. Once they send and receive the hello message, like I'm saying that hello, I'm A, and the router B replies I'm B. Now they know about each other. Now they become neighbors of each other. So the first step, they will send and receive the hello messages, and they will form the neighborship. They will establish the neighbor relationship, and they build one separate table called neighbor table. So I'll get into these tables separately. So I don't want to get into that table, all these tables in this video. Probably I'll be discussing in a separate video. So the first step, sending a hello message, getting a reply, and then building the neighbor table. Now the router A become a neighbor of router B. Router B becomes a neighbor of router A. That's the first step. Now the next step, once they send and receive the hello messages, now the next step is they need to exchange the routing information. So as of now, router A knows about B and router B knows about A. They know only their names, but they did not exchange any of the routing information. Now router A is actually connecting to some other more routers here, maybe some networks, some more routers. Now the router A has to exchange all the network information. It has to exchange with router B. That is the next step. So that's what it is going to do. It's saying it sends an update. It can be router A or B, whatever. So it's going to say, here is my complete routing information. So router A is going to advertise saying that hello router B, this is my routing table. So please take my routing table, and in this routing table I have information about each and every network, whatever I know, and what is the best route to reach each and every network. So it is going to exchange with router B because it's a new neighbor. Now the same thing happens opposite side as well. So anyway, anyone can initiate. So the same thing happens on the other side. They will exchange the routing information. You can see here, I listed here. Here is my complete routing table, and then here is my complete routing table. So this happens both the sides, And once you send the routing table information, it is going to send a confirmation message. So EIGRP is a reliable protocol. Whenever you send any update, it is going to send the acknowledgement, a confirmation message saying that yes, I received this update, something like that. So this is your second step. In the second step, every router will exchange its routing table, and that routing table contains all the best routes for each and every network, which means let's say I have some 20 networks and I have some 20 routers connected, 20 networks. I'm going to exchange all this network information with my neighbor. Now automatically router B will come to know about all the networks. Now the same thing happens here as well. Router B also may be connecting to some networks here, and the router B will exchange all that information with router A. So router A comes to know about all these networks, and the router B comes to know about all these networks. So this is the default process, what happens in between every two routers. So the first step, sending and receiving the hello messages, that's what we discussed. And then after that, they will form the neighbors, and then they will exchange the routing table. So they is going to exchange the routing table, and based on that routing table information, they will build another table called topology table. The topology table contains a list of best routes learned from each neighbor. We'll get into that more in detail in our next videos. So just assume that they will exchange the routing table, and tables we'll discuss. And after that, it is going to run the algorithm, and it's going to calculate the best route. So which means based on the information, whatever is received by the router is going to say, okay, so I received some routes information from this neighbor, and also I'm receiving from this neighbor, every neighbor. So I'm going to compare all those routes, and I'm going to calculate the best route and write on that best route in my routing table. Okay, so the networks get converged, and after that it will calculate the best route. So it's going to use something called dual algorithm, and to find the best route, it is going to use bandwidth, delay, load, MTU, reliability. So probably the metric calculation, we will be getting into that more in detail in our next videos, and also we'll get into the tables, discussing the different types of tables and what are the differences between neighbor table, topology table, and routing table much more in detail. So the basic process is very simple. They will send and receive the hello messages, and then they will exchange the routing information in the second step. After that, they will send the acknowledgements, and finally they will calculate the best route and write on the best route in the routing table. So in simple, I can say the initial process is going to be in 3 steps. So here you can see updates are sent on multicast address, and there is one more thing. Initially, just now I said, okay, they are exchanging the routing information, and the next update, they will not send the next update unless and until there is a change, which means, if you remember, we discussed it works based on incremental updates. Whenever there is a change, then only the next update will be sent. But still, the router A will be sending hello message for every 5 seconds, and the dead time is 15 seconds. So which means if the router B do not receive hello message for 15 seconds, which means first hello 5 seconds it missed because the interface is down, and next hello again I didn't receive the next 5 seconds, and the third hello. So which means if the router B or router A missed 3 hello messages, it will understand that the neighbor is down, and it will start using the alternate route after 15 seconds. So which means the convergence is much faster here. Why? Because by default it is going to send hello for every 5 seconds, and the dead time is 15 seconds, and it's much faster than any other routing protocol, we can say. And it's going to use 224.0.0.10 is the default multicast address reserved for EIGRP messages. So all the EIGRP routers listen on this particular address, 224.0.0.10. Now let's go ahead and verify practically the behavior of whatever we discussed just now, whatever the 3-step process. So for implementing and verifying the basic EIGRP process, I'm going to take 2 routers, and both the routers are pre-configured with this IP addressing. So which means I'm going to the router will send a hello message on this interface, and the reply will come on that particular interface. And I have a 10-dot network. I want to ensure that this 10-dot network should communicate with 20-dot network. I'm going to use EIGRP with autonomous system of 100. So the advertisements are very simple here. We just need to go to router EIGRP, and then we need to use some AS number, any number we can use. I'm going to use 100, and then we need to advertise 1.network, and there are two network commands we need to use. We need to say 10.network, and I need to say network 1.network. So the same thing I need to do on the router 2. On the router 2, just I need to replace with 10 20.network. So we need to advertise 1.network and 20.network. We need to advertise our own directly connected interfaces. So that's something I'm going to verify, and there are some specific show commands which I'll be using. So I'm going to use some debug commands. Debug commands are like the commands which whenever you enable debug, not recommended in the production networks, but debug is going to show you the backend process, what is exactly happening. So I want to verify what is happening, the EIGRP packets. So I'll be using debug EIGRP packets, and apart from that, I'll be using show IP EIGRP interfaces to verify which interfaces enabled with EIGRP. In my scenario, these are the two interfaces where I'm going to enable EIGRP. And apart from that, I'll be verifying the neighbor table, and then I'm going to verify the routing table by using show IP route EIGRP. So let's go ahead and verify the lab. Okay, so the first thing, I'm going to take this topology here. Okay, so this is my topology on the left side. So I need to start routers. So I got my pre-configured topology. If you remember, I'm going to start only two routers, that is router 1 and router 2. And if you remember, we have already discussed the basic setup of our topology in our earlier classes. So I'm going to start router 1, router 2. I just started. So the routers are booting here. On the left side, you can see the diagram very clearly, and on the right side of the screen, you can see what's going on here. So even the same lab is documented in my workbook. So I'll say EIGRP process. So there is a lab where I'm going to verify the EIGRP process. So the same steps I'm going to show you practically here. So the first task here, I'm going to open up the default topology, which I already did, and I'm going to start router 1, router 2, and I'm going to verify the pre-configurations, initial configurations, and ensure that all the interfaces are working and they should be up. So let's do that first on the router 1. So I have something called show IP interface brief. On the router 1, I have F0 by 0 and S1 by 0. So these are the two only interfaces we'll be using for practicals. And then I'm going to say show IP interface brief on the router 2. Again, you can see 20.network and 1.network. So as of now, I just have only IP addressing configured. I don't have any of the routing protocol running. So we don't have any routing running here. So the first thing, I'm going to configure routing here. So as we discussed already the commands, so we need to go to router 1, and then we need to say router EIGRP 100, and then we need to say network. What are the networks we need to advertise? 1.network I need to advertise, and then I need to advertise 10.network. So the same thing, this is on the router 1. So if you're doing on the router 2, then we just need to replace this with 20. Apart from that, everything is same. So advertise 1.network and 20.network. Let's do that. So I'll start with router 1. On the router 1, router EIGRP 100, and then advertising the 10.network. Okay, so before I actually do this, the first thing, I need to enable the debug EIGRP packets. Just I want to see the backend process, the update messages, everything on the backend. Okay, apart from that, there's nothing required. So I'll go to router EIGRP 100, and then I'm going to advertise the 10.network. So once you enable 10.network, you can see it's going to send a hello message on F0 by 0 interface. Whenever you advertise, it's going to send, and it is going to periodically send for every 5 seconds. So that's what you can see, 237, and next hello message is on 242, 5 seconds. So this is something you will continuously see. When you enable debug, you just need to be a little bit more careful, because sometimes it will be very difficult for you to type, because you'll see debug messages keep on coming depending upon your the debug commands which we used. So I'm going to say network 1.network. So once I enable EIGRP on 1.network, once I press enter, you will see hello messages will be sent also on S1 by 0. You can see here, you can see it's keep on sending this. As of now, the router 1 is just sending the hello messages, but we are not receiving any reply. So it's sending on multicast address, but we are not receiving any reply, and the reason is we did not advertise on the other interface. Let's do that. So before I actually do that, so I lost the connection. Okay, on the router 2, let's do that. So before I actually, so enabling debug commands is really not really required to do, but it's really a good way to verify the process. So I'm going to say debug EIGRP packets, done. So I'm going to say router EIGRP 100. I'm going to advertise the LAN interface 20.network here. Now, once you do that, it starts sending the hello messages on that interface, but you don't get a reply on that. So I'm going to send 1.network. So once I press enter, you will see the complete process happens in fraction of seconds. Let me just press enter and observe the output. You can see there's a lot of messages, outputs going on both the routers. And now I'm going to disable that, undebug all. There is something called u undebug all. So better you disable that, because if you want to observe, because it's keep on scrolling all these messages. So I want to undebug all, undebug all. So I disable the debug. Let's go up and verify the debug messages here. So I'm going to verify. You can see this is a hello messages. It's keep on sending now. Okay, so here you can see sending an update. Okay, so now here you can see it is sending a hello message, received a hello message here. That's what you'll see, received a hello message, because once you advertise this interface, it will reply to that hello message saying that okay, so once it's sending the hello message, and now it can see it's received a hello message. After that, it is going to send an update. So if you just calm down a little bit. Okay, so here you can see sending an hello message and then receiving an hello message, receiving an update. After that, it is sending an update and then receiving an update. This is the second step which I discussed. And after that, it will send some acknowledgements. And finally, after that, the next update will be sent whenever there is a change. Okay, this is the default process. You can see, in fact, you will see a lot of outputs here, but you just need to understand that, okay, whenever you send any update, it's going to receive an acknowledgement after that. And whatever the process, and after that it will keep on sending hello messages for every 5 seconds. So this is something, sending and receiving the hello message, it happens for every 5 seconds, and based on these hello messages, the neighbors or the routers will actually come to know whether the neighbor router is still available or not. Okay, and if that hello message is missed for next 5 seconds, let's say I'm going to shut down the interface, but before I shut down, I'll enable the debug. So I'm going to debug EIGRP packets, and you can see, but before that, let's verify show IP EIGRP neighbors. So you can see on the router 2, I'll go with router 2. So on the router 2, you can see a neighbor, the neighbor table. So the neighbor is 1.1.1.1, that is router 1, and it is connecting on S1 by 0 interface. And you can see this is the default timer here. So once this timer reaches to 0, automatically it will remove the neighbor entry from the neighbor table. So for verification, what you can do is you can try shutting down the interface. I'll say interface S1 by 0. I'll shut down this interface. And if I verify show IP EIGRP neighbors, you'll see the neighborship is removed here because the interface is down. Automatically it will, on the left side, here you can see it is sending the hello message, sending the hello messages, but once it reaches the hold on time, when neighbor 1.1.1.2 is down because the interface is down. So automatically if the interface down, the router will come to know that the neighbor is down, and it will remove the neighbor entry from the routing table. Okay, so probably we have some more outputs, like we'll be verifying much more in detail, like show IP EIGRP topology, verifying the topology table, show IP route EIGRP. So as of now I don't see the routing table because the interface is down. Let me just make the interface back to up, S1 by 0. Let's say no shutdown. Now once again no shutdown, again the interface will come up. Now once the interface is up, it will start receiving the hello message. Okay, so once the neighborship is up, so you can see the neighborship is up, the new adjacency has been established, and the neighborship is up. And if I verify the routing table, I can see 20.network is learned through EIGRP. So this is the way we can actually verify the basic EIGRP process. Now for verifying, we just did only two things. We just configure the basic EIGRP, and then we verified with some specific debug commands. We used debug EIGRP packets for verifying the backend process. Probably you'll see the 3-step process: sending and receiving the hello messages, and then you'll also see sending and receiving the update, and also the acknowledgement packets you'll see. And finally it is going to calculate the best route. The best route calculation anyway we'll see based on EIGRP metric, and also we'll get into much more in detail about the EIGRP tables in our next video.